All right, here's a video on how to do 4.3, the sine law. Okay, so it says here that the goal of using the sine law is to be able to solve for sides and angles in non-right triangles. And once you have a triangle that's not a right angle triangle and you're being asked to solve the sides and angles, your go-to move should be the sine law. Okay? In fact, the sine law can be used for any triangle as long as you are given a side and an opposite angle to match. Okay? Then at that point, one other side or one other angle, and you can actually work it out. Okay, so there's a lot of benefits to it. The only time you can't use sine law, whether it's for right angle triangles, non-right angle triangles, the only time you can't use the sine law is when you don't have a matching angle and side across from each other. Okay, in those cases, you're going to have to use a cosine law, which is 4.4. But let's get back to this. You can see here the steps for solving sides and angles with a sine law. Okay, first you want to ensure that the triangle provides one matching side and an angle, or one more side and angle. Um, then label the vertices with uppercase letters and the lowercase letters for the sides, and then substitute the values into the sine law. Eliminate the unused ratio and cross multiply and isolate the variable. Okay, so this is the sine law right here. It says sine A over lowercase a is equal to sine B over lowercase b, which is equal to sine C over lowercase c. This is under the assumption that you would have labeled the triangle as such, A, B, C. Of course, calling it the vertices A, B, and C, you could have, called the top one B, the bottom one A. It doesn't matter if you switch up the letters. What's important, however, is after you label the vertices, you have to label the corresponding sides directly across with their matching lowercase letters. Okay, and so therefore this here would have to be C. Notice we no longer have anything like the hypotenuse or the adjacent or the opposite sides. Those things unfortunately can't work because if you remember labeling those, you always label the hypotenuse first, which we no longer have. The hypotenuse is the longest side of a triangle as long as it's directly across from the right angle. We don't have any right angles. Okay, so let's move on. Um, Remembering that capitals are for angles and lower cases are for sides, always. So here are the conditions for the sine law. You just have to have a matching angle and a side. So if you look over here, you have an angle and a side, and they're matching, right? And you also have one other angle. And then you can just use the sine law and figure out any other angle or side that you're missing. Over here, let's talk about this one. You have a matching side, matching angle, and you have, in this case, one other side, not one other angle, but one other side. That's okay. You can figure out either one of these angles or the other side there. It's all something that you can work with a sine law. The one thing I want to highlight, though, is this one over here. If you look at it, you have a, a side without a matching angle here. It wasn't given. Okay, so well, you got an angle, but again, no matching side. And then here you have an angle, but no matching side. So how is this an example of matching angles and sides? Well, all you have to do is figure out what this angle is by subtracting the other two angles from 180, right? Because you know that the angle sum of any triangle is 180. So if I've already given you this one and this one, of course, then you can subtract them from 180 to be able to get this one. Once you have it, then again, you have a matching angle and a side. Okay, so we call the first one angle, angle, side. We call the second one angle, side, angle, and then we call the last one side, side, angle. Problem one, use the sine law to calculate the length of side B. All right, so here's side B right there, okay? And how do we know we got to use the sine law? Well, just by looking at it, I can tell you we don't have a right angle triangle. Okay, there's no right angles. Like if this is 49 and this is 86, this would have to be 90. But if you subtract them from 180, unfortunately, this is not 90. Okay. Also, I didn't draw in a 90-degree angle anywhere, so you can just assume it's not 90 degrees. So the first thing we need to do is go ahead and label this triangle. And you can see the vertices already plugged in with capital letters, and directly across from each vertice should be the lowercase version of them to mark the sides. Okay, so now that you see it set up, you should also spot that you have a matching angle and a side. Okay, now we are trying to find the lowercase b there. But let's see if we have a matching angle and a side. Yeah, we do. The a and the lowercase a. Okay, and then in this case, you have the b, but you're also trying to find the lowercase b. So let's write out the sine law. All right. And after writing out the sine law, we are now going to move ahead and plug in our values. Notice I didn't put in anything for angle C or side C. I could have found angle C by subtracting it from 180. That is possible. However, I do want to highlight the point that we don't need it. Okay, we don't need it. We're not being asked to find any like angle C or side C. In fact, what we're trying to find back at it is side B. So if we're trying to find side B, we definitely need this ratio, the sine 86 over lowercase b, and we should also use the sine 49 over 9. This will help us to be able to create a equation where we can solve for a variable in the equation, as long as the equation has only one variable, and this is the case. So what you do here, let me show you the steps, is we are just going to engage in some cross multiplying like this, and that will look like this. B sine 49 is equal to 9 sine 86. Notice I'm not writing something like sine 86 9. That would look like sine of 869. I wrote 9 times sine 86, not sine 86 times 9, just to avoid that. Okay, and over here we are just going to bring it home by getting the lowercase b isolated. And after that, sine 49 divided by sine 49 is 1, so b times 1 is simply b. And on the right side now we have 9 times sine 86 divided by sine 49. If you do that on your calculators, you should get 11.896, which, because we are being asked to calculate the length of side b, if it's a length and we don't specify the units or the rounding, then what you want to do is just go with one decimal place. And the number after the 8 is a 9, so that's going to push the 8 to become a 9 by going up 1. So it looks like the answer is 11.9. Okay, I'd include units, but there are no units here, so this is good enough. 11.9. Moving on. It says here, use sine law to calculate the measure of angle E. All right, we just did sine law to calculate a measure of a side, and now we're going to do an angle. All right, so angle E is this right here, and we need it. Okay, we don't have it. Can I just subtract it from 180, the other two? Unfortunately not, because I don't have angle D. I can't just subtract D and F from 180 to get E. It would have been nice, but unfortunately not. That's not an option. So let's look at what we have by first labeling out the triangle. Lowercase d here, lowercase e here, lowercase f. Make sure that the sides are directly across their angles, okay? This is very important to get the step right. Otherwise, if you mislabel your triangle, you will substitute incorrectly and also come up with the wrong answer. So anyways, let's not forget, we are looking for angle E up on the top. So we will start by writing out the sine law. But let's pause for a moment and recognize that we are using variables D, E, and F. So I'm going to write the sine law with those variables. Okay, now that we have that, let's go into the substitution phase. All right. At this point, we should be able to get rid of one of these ratios, and that's this one. It's not needed. Okay, and looking at what we do have, let's just make sure we only have one variable we need to solve for, and that is the angle E, and that is correct. Okay, now up until this point, I hope you understand that whenever we are trying to find an angle, we have to use the inverse of that trig function, right? And that's where you see sine inverse and cos inverse and tan inverse. If you are recognizing the pattern, you use the inverse of those functions whenever you're trying to find an angle. In fact, you can also say the reverse. If you're trying to find a side, you will not be using the inverse of sine, cos, and tan. Okay, so let's just prepare ourselves. We will be using sine inverse at some point, and let's see it. Let's bring out the little cross multiplying, and we'll see this become 26.4 times sine E is equal to 38.2 times sine 29, and we are going to at least get the 26.4 off of the left side by dividing it out on both sides, and we'll get something that looks like this. Okay, but the left side unfortunately still says sine E. We're not looking for sine E, we're looking for E. So what we do is we write E is equal to the sine inverse of this whole right side here. Okay, and you can punch this into your calculator. Make sure you round it to the nearest whole number, and you should get 44.547. And we're going to round this to the nearest whole number, so we're going to call this 45 degrees. Okay, angles, you want to round to the nearest whole degrees, unless it's specifying that we want to the nearest tenth, or if the angle is somehow being used as a part of the calculation and is going to be used for another part, so we want to keep it as accurate as possible. Okay, but as a final answer, round to the nearest whole number is typically what you want to do for an angle. All right, let's move on to the very last question here. And this last question says, through Shannon and Jay, each threw their empty juice box to the garbage and missed. Very typical occurrence in a classroom. The juice boxes landed 162 centimeters apart from each other. And through Shannon calculated an angle of 74 degrees to the garbage from his juice box, and Jay measured that he was 233 centimeters away from the garbage. So draw and label a diagram and determine who was closest. Okay, so we got some values that were given, and the first thing I need to do is to be able to provide some perspective is which one is through Shannon and which one's Jay. So just in terms of their order of appearance, let's call this one through Shannon with a capital letter T, and let's call this Jay with a capital letter J. Okay, and this one shall be G for garbage. So if we continue our process of labeling, then that means that this will be lowercase letter t, this should be lowercase letter j, and this should be lowercase letter g. At this point, we have the vertices and the sides labeled, which is great. And we can come in now with some of these other details that we have in the story. For instance, the juice boxes landed 162 centimeters apart from each other. So this should go here. What else? Through Shannon calculated an angle of 74 degrees to the garbage. So this is through Shannon's juice box. So this should be 74 degrees. And then Jay measured that he's 233 centimeters away. Okay, so let's just be very clear. Draw and label the diagram, and we need to determine who was the closest. Okay, so let us not lose sight of our goal. Who was the closest? So the first thing we need to recognize is we can't assume that we have a right angle triangle. Okay, there was nothing that indicated that we have a right angle triangle in the story. You can see in our diagram we should have drawn a right angle triangle, and we haven't. And we are not going to assume that any of these angles is 90 degrees, because even if it did happen, that's just by accident. We're throwing garbage at a garbage bin. Okay, so let's assume that it's not 90 degrees. We know that Thucana has a 74-degree angle, and we have a matching 233 here, which is great. Of course, this is pointing us towards using the sine law. Um, I also have a 162 here, which is good because, using the sine law, I can actually figure out this angle G. But really our goal, however, is to find side J. Because if we know side J, we can make a statement and say which one's actually a shorter distance. Okay? But to get side J, we need angle J. All right. So let's figure out our game plan. We're going to start by finding angle G because that's all the information will allow us to get. But after we have angle G, we can subtract angle G and angle T from 180 to get angle J. And then from there, we can do the sine law again and figure out side J. Okay, so first things first, let's go with angle G. We're going to set up the sine law, and we're going to say the sine of G over lowercase g is equal to the sine of, and we're just going to cut straight to the chase. We know that we have capital T and lowercase t, so I'm just going to write that there. Okay, and because we only need these two parts, I'm not going to bother writing out j and j. It's not necessary. Okay. And let's just keep to our focus here. Let's plug in what we do have, and you're going to see that we have sine G over G, which is 162, is equal to sine T, which happens to be 74 over 233. And of course, we have a ratio where we are comparing these two fractions to each other, and we have one unknown, which is fine. Let's multiply both sides by the 162. And be on our way with isolating that G. These guys will go out, and we've got sine G is equal to what would be 162 sine 74 all over 233. And to get G isolated, I'm going to do is equal to the sine inverse of it. (162 sine 74 divided by 233). And it turns out that G is equal to 41.94 degrees. 41.94 degrees. And I rounded it to the nearest hundredths because this is an angle that we still need to do some work with, right? This isn't our final answer. So I can write the 41.94 here, and that'll be angle G. All right. So if we have angle G, there, we are well on our way, right? 41.94 degrees. So let's figure out angle J. Let's do this in a different color. I can use this spot over here and talk about angle J, which we need. Angle J is a result of you can write J is equal to 180, subtract the 74 that we got and also the 41.94, if I can write that properly. And we're able to get that angle J is equal to at least to the nearest hundredths, about 64.06 degrees. Now that we got angle J, we can set up a sine law ratios to figure out lowercase j. So let's bring it home. This is what we'll do. We're just going to set up the sine law real quick again, but this time using our lowercase j because we finally got to that point. So we're going to write sine of j divided by lowercase j is equal to the sine of what we were actually given originally, t over lowercase t. Notice I didn't use sine of g over lowercase g because the angle g, 41.94, is a rounded value, and you don't really want to use that in calculations if it's possible. And to avoid it, in this case, we can avoid it because we're just going to use the given numbers of 74 and 233 that the question gave us. So if we plug in from here, you're going to end up looking like this. Sine of j, which happens to be 64.06 over lowercase j, which we don't have. And then the sine of t, which is 74 over lowercase t, which is 233. And then when you do your cross multiplying, and you would get j sine 74 is equal to 233 times sine 64.06. Divide both sides by sine 74 so we can get j. And you get j is equal to 217.9696, which we're going to round to 218. 218 centimeters is lowercase j. Okay, is that our final answer? Actually, no, it isn't, because the question originally is who was closest. So to answer that, we have to say if this is 218 centimeters, and this is 233, it looks like the 218 centimeters is closest. So I'm going to go with through Shannon's juice box. Okay, so therefore, through Shannon was closest to the garbage. And light blue. All right, this is how you use the sine law to solve a non-right triangle. We just covered a side, an angle example, and then also this example where we have an application question. All right, have a great day. Goodbye.